Hello, welcome to another tutorial on Computer Science GCSE. Today we're going to be going over the CPU. So the CPU is like the brain of the computer. It's the most important hardware component, and without it, the rest of the computer would just be a giant metal paperweight. The CPU has two main functions. The first is to process data and instructions. So this is through something called the fetch execute cycle, which we'll be going over in next video. So von Neumann Architecture, if you've already read ahead a little bit. And the second function is controlling the rest of the system's hardware. So that's stuff like RAM, sound cards, GPUs, graphical processing units, and secondary storage. All general purpose systems, which the definition of which you might be familiar with now if you watched the last video, follows the same kind of procedure. You have your inputs, you send them to the CPU, and then your CPU produces outputs. And we also deal with memory. So main memory, RAM, feeds into the CPU with instructions, and then the CPU often writes to secondary memory. So your hard disk drives, solid state drives, USB sticks, CDs, that kind of thing. The CPU has a few important components that we're going to talk through as well. So the first is called the Arithmetic Logic Unit, which is shortened to ALU. So this is kind of a common theme in the GCSE. There's quite a lot of acronyms. Don't be overwhelmed, just try to remember the full names, and that generally gives you a bit more of a clue as to what's going on. So the ALU performs all of the maths and logic operations within the CPU, as well as all the data from main memory, so RAM, passing through the ALU in order to get to the CPU. So this is a little bit more relevant when we do the von Neumann architecture, but it's just a couple of things to note. The CU stands for control unit. So the control unit is responsible for essentially sending out control signals, so instructions, to all of the other hardware components on the system, as well as sending control signals to the different components in the CPU. So the control unit is responsible for fetching, decoding, and executing instructions from main memory, and sending these control signals via the control bus. We'll be going over buses in a couple of slides as well. I just want to note this thing about the clock. So sending timing signals. So the clock in sort of the actual CPU, not within the GCSE version of the CPU, is an entire component within itself. The CPU works like one giant circuit, and circuits have frequency, which we call clock speed, which we'll also come on to in a couple of slides. But because the CPU works like a giant circuit, things happen rhythmically. So because it has a frequency, we need to keep everything in time with one another, because if things started being done out of time, that would lead to a whole host of errors that would be really difficult to handle. So the clock is kind of like the metronome. It sort of keeps the beat of the CPU going. In this version of the GCSE, we kind of say that the clock is a part of the control unit, whereas normally it can be considered a separate component within itself. And then lastly, we'll talk about cache. So cache is memory on board the CPU. So it works in a really similar way to main memory, RAM. It's essentially an intermediary. So because it's much faster and much closer to the CPU than RAM, we store a lot of the common instructions in cache so that it can basically just do its job quicker. The less times we have to call from RAM, the better. So cache will just keep the really, really common stuff there closer for us. Right, so on to factors that affect CPU performance. So the first thing we'll talk about is clock speeds. This is kind of what I mentioned. This is the frequency of sort of cycles per second in the CPU. The CPU is a circuit, but it's also ridiculously quick. Often a modern CPU will have a sort of 2 to 3 gigahertz clock speed, which means 2 to 3 billion operations per second, so 2 to 3 billion cycles per second. I just want to note, if you've already sort of done the fetch execute cycle, 2 to 3 billion cycles per second does not mean 2 to 3 billion fetch execute cycles per second, because a fetch execute cycle, as we'll go over, often takes sort of between 5 and 10 cycles to actually complete. But this is the amount of times per second that data changes from one register to another. So the state of the CPU changes effectively. So there's also some numbers there for you. So just a gigahertz being equal to a billion, as you'll probably see in the units and numbers section, which is in 2.6. So the next factor that affects performance is the cache size. So essentially increasing cache size means that we don't need to fetch from the slower and further away RAM quite so often, which leaves more time for processing. So that one's a bit more intuitive. And finally, the number of cores. So a core acts like an independent processing unit. So if we have two cores, that means that in theory, we can process two things at the same time. However, it's quite important to note that increasing the number of cores does not necessarily increase speed up by the same kind of factor. So if you had four cores, that wouldn't reduce the time taken to complete by 75%, quartering it like you might expect. The best way to explain this is if you imagine you're cooking a meal, having a second person helping you cook might reduce quite a lot of the tasks by two. For example, if you're cutting vegetables, having two people on veg would probably double the speed at which it's cut, which makes sense. But now imagine you had 16 chefs all in one tiny kitchen. It'd actually probably slow you down a little bit because you'd spend so much time telling people what to do, or people would just be sitting idle and not really contributing, just sort of getting in the way. Kind of works the same with cores. We have kind of a static overhead, which I won't really get into. An overhead basically just means some processing that has to be done to even consider cores. So that would be the algorithm that decides which tasks go to which cores. So too many of them for tasks that don't really require it won't actually provide that much speed up. So there will be a question sort of within my pack that kind of delves in on this. So a bit of a spoiler there. But essentially, if you could take the choice between a, say, 2 gigahertz CPU with one core over a CPU with two cores, each 1 gigahertz, you're probably better off with a single core because you're guaranteed to get 2 billion cycles per second. Whereas with two cores, each with 1 billion each, you're not necessarily going to get the equivalent power output. Right, that's everything on CPU and its performance. Thank you for watching.